Hello everyone, in this video, we are continue learning the differentiation. If we see a function with more than one term, we need to differentiate the terms one at a time. For example, there is a quadratic curve with the equation y equals to ax squared plus bx plus c. So we differentiate each term. So we have the term that are ax squared, bx, and c. Then you differentiate the first term, ax squared, we have 2ax. For the second term, we have b, and for the constant term, we have 0. You can see that for the constant term, it disappears after you differentiate it. So, the derivative of y equals to 2ax plus b plus 0. That equals to 2ax plus b for the quadratic equation. In general, if you have y equals to fx plus or minus gx, then dy over dx equals to the derivative of fx plus minus the derivative of gx. Now let's do some example questions. Question 1 said, you need to find dy over dx given that y equals to the following expression. For part A, we have x squared plus 4x. So we write down dy over dx equals to, we're doing the differentiation for the first term, that is 2x. And for the second term, that equals to 4. So the differentiation of x squared plus 4x equals to 2x plus 4. For part B, let us see, we have the first term 3x squared, and we differentiate the first term, we have 6x. And for the second term, we have negative 2x, and we differentiate it, we have minus 2. For the constant term, we have 7, and you differentiate it, we get 0. So the derivative of 3x squared minus 2x plus 7 equals to 6x minus 2. Now let's move on to the question 2. So we have fx equals to 3x squared minus 5x plus 2. The question said that you need to find the gradient of y equals to fx at the points where the curve meets the line y equals to negative 13x plus 5. So at first, we need to find the points of intersection. Which means we need to find the value of x when 3x squared minus 5x plus 2 equals to negative 13x plus 5. And we rearrange that, we have 3x squared minus 5x plus 2 plus 13x minus 5 equals to 0. We have 3x squared plus 8x minus 3 equals to 0. We can see that we can factorize the left-hand side. So we have 3x minus 1 times x plus 3 equals to 0. This, we have 3x minus 1 equals to 0, or x plus 3 equals to 0. So we have two values of x that are x equals to the third and x equals to negative 3. We know that the point lays both on the fx and y equals to negative 13x plus 5. The question said that you need to find the gradient of y equals to fx. Then we need to write down the derivative, we need to find the derivative of fx. We know that fx equals to 3x squared minus 5x plus 2. So we differentiate it, we have 6x minus 5. Now we can substitute the value of x into the derivative of fx. When x equals to the third, the derivative of fx equals to 6 times thirds minus 5 equals to negative 3. This is the first gradient, and when x equals to negative 3, the derivative of fx, let me write down that it should be, here should be third, here should be negative 3, equals to 6 times negative 3 minus 5 equals to negative 23. Which means the gradient of fx at x equals to third is negative 3, and the gradient of fx at x equals to negative 3 is negative 23. Now let's move on to see other questions. For the question 3, it asks you to find the dy over dx given that y equals to the following expression. So in here, there are not quadratic equation, so we can differentiate them term by term. So part A, we have 5 times x cubed plus 3x. Now let us differentiate the first term. We have 3 times 5 times x 3 minus 1. That equals to 15 x squared. Now let's differentiate the second term. So 3x, that is 3. So dy over dx of 5x cubed plus 3x equals to 15x squared plus 3. For part B, similarly we need to differentiate term by term. For the first term, we differentiate, we have the third times the half times x to the power of half minus 1. For the second term, we have 3 times 4 times x to the power of 2. In this case, we have 1 over 6 times x to the power of negative half plus 12 times x squared. For part C, we have y equals to 1 over 5 times square root of x, and we can write it as in another form. That equals to 1 over 5 times 1 over x to the power of half. That equals to 1 over 5 times x to the power of negative half. Then we can differentiate it. We have dy over dx equals to 1 over 5 times negative half times x to the power of negative half minus 1 equals to negative 1 over 10 x to the power of minus 3 over 2. Now let's move on to the last question. We have the function f(x) equals to 3 over p times square root of x plus 2x, where p is a real constant and x greater than 0. Given that the differentiated of f(x) when x equals to 2 equals to 4, find p giving your answer in the form a times square root of 2 to the power of 3, where a is a rational number. So at first, we can rewrite the function f(x). We have f(x) equals to 3 over p times square root of x plus 2x. That equals to 3 over p times 1 over x to the power of half plus 2x equals to 3 over p times x to the negative half plus 2x. Then we can write down the differentiate of the f(x). Find the derivative of f(x). We have 3 over p times half times x to the power of half minus 1 plus 2. That equals to negative 3 over 2p times x to the power of negative 3 over 2 plus 2. Given that if x equals to 2, the derivative of f(x) equals to 4. So we can substitute x equals to 4 into the derivative. We have negative 3 over 2p times 2 to the power of negative 3 over 2 plus 2. That equals to 4. As the question gives you the answer of that. Then we have negative 3 over 2p times 2 to the power of a negative 3 over 2 equals to 2. Then we have 3 times 2 to the power of a negative 3 over 2 equals to 4p. Negative 4p. Thus p equals to negative 3 times 2 to the power of negative 3 over 2, and then over 4. Equals to negative 3 over 4 times 2 to the power of negative 3 over 2. Well, as the question said that you need to write down in the form a times the square root of 2 cubed. So we need to change the form. We have negative 3 over 4 times 2 to the power, times 1 over 2 to the power of 3 over 2. That equals to negative 3 over 4 times 1 over square root of 2 to the power 3. Then we can times 1 over square root of 2 to the power 3 by square root of 2 to the power 3, both on the denominator and denominator. That equals to negative 3 over 4 times square root of 2 to the power 3 over 2 to the power 3 equals to negative 3 over 4 times square root of 2 to the power 3 over 8. That equals to negative 3 times square root of 2 to the power 3 over 32. So we have that A equals to negative 3 over 32, right? As you can see, equals to A times square root of 2 to the power 3. So we have the answer that P equals to negative 3 over 32 times the square root of 2 cubed, where A equals to negative 3 over 32. Okay, here is the end of the video. Hope you enjoy it. Thank you. Bye.